Progress Chef provides configuration management, compliance, remediation, and automation to allow organizations to maintain control of their infrastructure. These capabilities empower business with the flexibility to leverage Chef in the way that is most desired, or in many cases required, to support their operations at scale. In this presentation, we'll highlight some recently available and underutilized features that add significant flexibility to the core Chef technologies. The capabilities of these features include agentless management for devices and services that are incapable of installing Chef software, high-scale performance scanning for operations requiring continuous compliance against large node counts, and systems democratization to operation members familiar with configuration files but not code language structure. In the following demo, we'll interactively utilize Infra Target mode, Inspec Parallel Scanning, and YAML configuration alongside Chef's standard capabilities. The scenarios will include compliance scans using Chef Automate web user interface or initiating scans directly within the CLI, using target mode to manage the infrastructure for nodes where support for the Chef client may be restricted, and using both Ruby and YAML to build recipes to manage and remediate the nodes running in the environment. As a prerequisite for this demo, we have two virtual machines running OpenWRT, which will act as Target 1 and Target 2. OpenWRT is a Linux-based open source project for routers and other network devices. It provides a customizable and secure platform for network performance optimization. Various security features are made available, including firewall, VPN, and intrusion detection, all of which help protect against network attacks and unauthorized access. A compliance scan has already been created and scheduled to run on a set interval to ensure the proper configuration and firewall rules exist. In this example, we're running Chef Automate in our data center, but customers can also look at leveraging Chef SaaS, which is provided as a service. In the Chef Automate web user interface, the scheduled compliance scan against the OpenWRT appliances report there's some failed controls. The compliance profile that was created and run against these two OpenWRT systems has three controls within a single file. The first checks for an HTTPS firewall rule on port 443. The second check is for a file called ip.txt, and the last is for an FTP firewall rule blocking port 21. In this report, the OpenWRT01 is missing the HTTPS firewall rule and the ip.txt file. However, it does have the block FTP rule, whereas the OpenWRT02 has the HTTPS firewall rule, but is missing the FTP rule in addition to the ip.txt file. As mentioned earlier, the ability to confirm the same can be accomplished running these scans directly in the Chef command line interface. Running the scan against the first target, OpenWRT01, and specifying firewall in the command as the compliance profile name, -T indicates it's using target mode, and the authentication is using SSH into the machine with its IP address and password. As expected, the scan against OpenWRT01 has two failed controls, where the HTTPS rule and the ip.txt are missing. Running the same scan against OpenWRT02 shows once again the two failed controls, where the ip.txt and the block FTP rule are missing. Furthermore, looking on the OpenWRT web interface on each of these systems, we can confirm the same. A remediation script will be used to resolve these failed controls on OpenWRT01 using a Ruby recipe and target mode, since we don't have the ability to leverage the Chef client agent on these systems. This recipe will create a directory named IP_details and a text file within the same directory. It also has a few other mandatory settings and two firewall rules, the block FTP and the allow HTTPS. Running the Ruby recipe against the OpenWRT01 system with the command chef-client -z -t and the IP address. A credentials file is leveraged within this directory containing the necessary authentication information to access the system. Results indicate the ip.txt files created within the ip_details directory, and the allow HTTPS rule is configured on the target. Returning to the OpenWRT web interface and refreshing the page shows both firewall rules, the block FTP and the allow HTTPS, are now present. The compliance scan will be run again, but this time using a parallel scan against both nodes rather than individually. Inspec Parallel mode allows organizations to quickly scan multiple profiles on multiple targets, which can be used to scale to hundreds of nodes rapidly. Details of the remote machines are provided in a text file, which will log its output to two separate files, ruby-results.out and YAML-results.out. In addition, environmental variables can be leveraged while working with Inspec Parallel. The Inspec Parallel exec command will run the firewall profile against the nodes mentioned in the text file. Two separate threads are running in parallel against the two target machines, the results of which are logged into the log file directory. Looking at the output file, ruby-results.out, we have all three controls passed after running the Ruby recipe against the OpenWRT01 system. The file YAML-results.out still reports the two failed controls since we have not run a remediation recipe against that target yet. So for those who prefer writing in YAML, we can see all the rules are the same as in the Ruby recipe used earlier. Creating a file within a directory and configuration of the necessary firewall rules. Running the YAML recipe using target mode against the OpenWRT02 with the same command, chef-client -z -t and the IP address. Results indicate the ip.txt files created and the block FTP rule is set up on the target. Returning to the OpenWRT02 UI and refreshing the page shows the firewall rules, allow HTTPS and block FTP are now both present. Now that both systems are updated with the proper configuration, the last compliance scan will be run in parallel against both machines to confirm the results. The files ruby-results and YAML-results show all the controls passed. And now, when running the compliance scan on the scheduled interval in the Chef Automate web user interface, we can once again confirm that all controls have passed. With that, our demo is concluded. Thank you for your time and interest in these capabilities. We hope you found this information valuable, and we look forward to hearing from you about the problem-solving patterns and use cases in your own environments utilizing these lesser-known but powerful features.